Bam. Hi, everyone. Thank you so much for being here. Thank you so much, Chicago Innovate, for having me. My name is Yablonina. I'm an assistant professor at the Daniels Faculty of Architecture, Landscape, and Design at the University of Toronto, where I'm also a faculty member at the Robotics Institute, also at the University of Toronto. So I'm going to shift the gears a little bit. I feel like this panel, we've been talking about software a lot. I will not be talking about software at all. I'll be talking about these guys. So my background, I guess before we jump in, my background is technically in architecture. I'm trained as an architect. I have a master's of science and a PhD in engineering, and I wear a lot of hats. My home faculty seems to think that I'm an architect, and we're going to keep it that way for a bit. But my practice is mostly in creating machines, developing systems that involve custom hardware. And I like to refer to it as designing with machines, where what I'm actually doing is designing the machines themselves. And then through that process, the architecture sort of not just happens, but kind of happens at the intersection of those. So there are a bunch of different ways to contextualize the work, and I generally try to customize that depending on the audience. So I felt like this might be a more appropriate one for today. We know that there are robots in construction, there are robots in architecture. Nothing new, no rocket science, really. There's a lot of automation of existing processes, which is where a lot of the current developments in the industry are happening. So the processes that already exist, that are generally performed by human laborers, are being automated either into teleoperated machine systems or some semi-automated process enabled by sensing. And then there's this other flavor of robotics in architecture, which is still mostly married to research, mostly married to universities and educational institutions, where we're not necessarily automating existing processes, but looking at the machines that are already available to us, be that machines inherited from industry or otherwise, and trying to really come up with ways how they could enable new design spaces, new material approaches, new geometries, new programs, et cetera, et cetera. And a lot of that development happens around, I guess the field is no longer new. That's been going on for almost 15 years now, depending on where you count. But a lot of this happens around this type of machine. So usually it's an industrial robotic arm, which is not as universal as some would like to name it. It's a machine that comes from a very specific place, sort of the car manufacturing space, where it is universal in a way, but it's universal for as long as it's making objects that are car-like in a situation that is car manufacturing-like. So object is moving from station to station, machine is performing repetitive actions on said object. Sometimes the actions are sort of customized, but still within the general repeatability and kind of repetition of the same complex task scenario. So that's kind of this, or I guess this is the space where I sort of grew up and academically. And the more I was growing up in that space, the more I was thinking about how in inheriting these machines from car manufacturing, we sort of got ourselves trapped in a space where we make architecture that feels and looks and maybe scales in a way that cars do. And I'm not a big fan of that. So I've started in a very naive at the time way, thinking about ways how we could, instead of looking at the machine and figuring out what the architecture could be, kind of roll that system back a little bit, looking at the architecture again and thinking about what machines could be in that space and what machines can occupy those spaces. And I was specifically interested in looking at animal examples of species that inhabit spaces that are already there. And I was really lucky to work with Diane, who is terrifying and adorable at the same time. Diane required a lot of crickets to be fed to her, which was the most terrifying part of working with her. I'm also arachnophobic, so there's a lot of stuff going on. But I figured out how to become sort of friends at a distance with Diane. I was like, as long as you're behind the glass, we're fine. And what was really fascinating about this particular spider, or the species of spiders that I had the opportunity to study for a bit during my master's studies, is it's a very specific species that is very, very common in Germany and in Europe in general that has evolved to live in human spaces. It's, you know, that the right thing to do when you find a spider in your house, you like put it in a cup and you take it outside. Diana would be really upset. She'd be like, what is this tree bullshit? I wanted to be in the corner where you got me, whatever. So there are spiders that have evolved to live in our rectilinear environments. They really love corners. They really love these spaces behind cupboards. And as I was working with these animals and thinking about how they build, I started thinking about architectural spaces that have nothing to do with building from scratch, which again, I think is how a lot of architects are educated today. It's like you show up, there is nothing, and then through your greatness of brilliance, you've created a thing. And I've always wanted to think about spaces as something that can be repaired, something that can be maintained, something that requires attention and requires technology and research, because so much of the research and computation and digital fabrication that I was seeing at the time was to do with new stuff. So thinking about spiders and how they occupy existing spaces, again, in a very naive at the time move, I was like, I'm just going to build a machine that will exist in a space. And the machine that I decided to build first, or the machine that worked first, I guess, there were many, many iterations of failures in between, is a wall climbing, rope winding robot. As you see from the video, it's made of a bunch of off-the-shelf parts. There are some parts that are taken out of vacuum cleaners. There are some parts that are like off-the-shelf servo motors. There are some parts that are custom made, custom milled, and custom 3D printed. Of course, comes with its own software. So the machine can climb walls. It can navigate them with some sort of, I wouldn't say intelligence, but understanding of its environment. So it knows where it is. It knows where the target space is in a digital space, and it can navigate to said target. And my favorite part is you can also drive it with a joystick from an Xbox controller, which turns out is the best way to drive a robot. Xbox controllers are very useful tools. So two machines of the same type can meet in a corner of a room and pass this cartridge of material from one side to another. They can also approach anchors that are pre-installed by humans in the space and start attaching material. So repeating these two reasonably simple operations over and over and over again within a space that affords a certain amount of design and workspace freedom, the two machines can start creating three-dimensional objects. Whether or not these three-dimensional objects are architecture is very much up for debate, but I would say that they're definitely of architectural scale, at least interior architectural scale, and in the worst case scenario, furniture. Of course, the machines, as you see, I show up every now and then in the video. They need a lot of attention. They are very much prototypes, but they do build something of human-ish scale within spaces that already exist. And of course, this is these are early steps, but the speculation here is that potentially as we add more machines to the system, and as you see, I did go back to robot arms eventually with an apology saying like, I know you make cars, I don't like you, but can you come and help me out with this corner problem that I've had? So imagining alternative scenarios where, let's say we don't have a 90-degree corner in a room, how do we solve it? And I've been talking to a lot of people. Some people were like, why don't you shoot fiber from one wall to another and it sticks? And it's like, yeah, no, that's a bit too much even for me. So I've decided to go with another approach where machines become modules of larger systems. So for every new iteration or every new problem or every new design task, I've tried to think about ways to either invite an existing machine to help out or develop a new one to fill in the gap. And I guess this project was one of the first large-scale ones where that methodology became both clearer for me myself and kind of crystallized this power of task-specific machines that are, yes, very narrow in application, but in combining them in different ways, we can actually achieve quite a bit. So here I was asked to do a installation at the Milan Design Week back in 2017. Was absolutely terrifying. I've never done anything at an institution that seemed that important at the time. I've never done anything that big. That was a lot of firsts. So they had a space where they had two walls positioned at roughly 7.5 meter distance from each other. I had my wall climbing robot system already with slight design changes and upgrades, but the gap between the two walls, of course, had to be crossed somehow. So I add a new machine, which is a very, very simple single axis cable driving robot. I lovingly called it Peter Parker, which is the only machine name that's ever stuck, which is strange. So Peter goes between the walls and passes the material from one side to another. Is that system efficient? Big question mark. But did it work, and did it help me kind of prove a point and move on with this type of practice? Absolutely, 100% yes. And what was really striking, and I guess in retrospect striking to me, is thinking about the design space that these types of machines can afford. And because frankly, when I started developing it, there was a deadline, I was in a rush, and I was like, throw things together, it'll be fine. Fly to Milan with 2 suitcases that contain all of the robotic equipment, which is kind of cool. And again, from that kind of, one of the suitcases contained my clothes. But from the other suitcase, all the robot tools came out, the rope was there on site, and we managed to fabricate this humongous, by my, at the time, standards sculptural object. And what's more interesting is, again, thinking about design spaces and thinking about work envelopes, each of the machines is pretty silly and kind of flat. The work envelope is very, very limited. The wall climbers can only climb along a surface. The shuttle robot is a single axis machine, but by combining them, we suddenly buy ourselves the whole volume of a room. So when you take the same system, bring it into the new room, it scales both up and down. And I think the scaling down is something we don't talk often enough in architecture. So thinking about these sort of overlapping machine spaces, overlapping design spaces, I was again really fortunate to be invited to do another installation, this time in Linz for Ars Electronica in a year that I don't remember, where I started thinking back into the system that I already have and figuring out how it could be adapted or changed to a slightly larger work envelope or a slightly more efficient process. So one of the things that happened in Milan is that each of the wall climbers sat there for longer than it actually did anything, because it goes, it attaches the rope, then it passes it to Peter Parker, and while the Peter Parker and the other wall climber are doing their thing, this one just sits there. And not only is it sitting there, it's also actually overheating a motor. Those robots can only be operational for roughly 20 minutes at a time, then they need a break because the motor is still taken out of a vacuum cleaner. So I started thinking about other types of locomotion systems that wouldn't take as much energy, other types of machine cooperation systems that would work sort of in parallel. So you see now we have 2 shuttle robots. So that means that both vertical machines can operate almost continuously. And also thinking about other architectural objects that I could actually attach to. So moving slightly away from walls onto maybe some sheet elements, be that windows, be that panels, be that facade elements. So for this system, we've set our environment ourselves. So we had the pleasure to sort of curate the in situ space on which the machines could operate. But and I've ran some tests of similar machines on double pane glass, which works really well. So this one is a magnetic sheet climbing robot that, again, in cooperation with a shuttle, can perform these anchoring routines and passing routines, and over time create objects of, if not architectural scale, but at least sculptural, and definitely proving some points here. Again, the human is very much involved. These machines are not products. I don't know if they ever will be or need to be. They're prototypes, they're ways of thinking about machinic systems, they're ways of thinking about how we approach architectural space with technology and with machine. And again, they are sort of proof of concept of these in situ work envelopes that consist of elements, architectural elements that are already in place. And if we can use those elements as locomotion substrates, we can buy as much space as there is already in our space. Hello. So the next project that I want to show you is one of the last ones in the series of sort of more art installation ones where, again, I was invited to do an exhibition. I showed up on site and I was only 15 minutes in. I thought I had 20. Or I can wrap up. So I showed up on site. There were no walls, there were columns and beams instead. And I was like, fuck, I only have wall climbing machines. So I had to figure out another way to deal with this. And basically, the immediate, I guess, strategy that came to mind is why don't I'm still going to leverage the structural capacity of the space, but I will install an extra system of railings. They are not structural. They're basically just for the robot to be able to attach to something and localize itself in space. So similar to the previous examples, I have two machines. One does the winding, another one passes the material from one point to another. You'll notice that they're not carrying the bobbin anymore because the bobbin became a problem in terms of scale. And the vertical machine can, again, attach rope to human pre-installed hooks, and then the horizontal one picks it up and passes it onto the other side of the frame. The anchoring machine works both on vertical and horizontal surfaces, which was really fun to figure out how to do that. Basically, there's a sort of fillet element at the corner of the frame that the robot can traverse. So the robot doesn't actually know that it's upside down. It's just going along a single kind of dimension of the rail. But the mechanism is designed such that it's not entirely gravity agnostic, but it's gravity agnostic in one direction. So as these machines work together, and here we have 6 of them working in parallel, they create this kind of space where the fabrication process never really stops. And that's what's always been very important for me in all of these art projects, where it's not just about show up, fabricate something that looks kind of nice and fancy, and then leave the object behind. It's more about show up, install the robots, and have them build and build and build. And the process, like, they're meant to stay in the space. So as the exhibition continues, the space changes, it adapts. It doesn't really adapt in a day, but if you were to come back to the exhibition 5 or 7 or 10 days later, you would see the system in its various stages of being wound and unwound. So how does all of my art practice relate to construction? Very good question, which I've had myself up until I was very lucky to be approached by Zainer a couple of years ago with a really, really difficult project that I'm sure you'll recognize. I'm not going to go into describing what it even is, but one of the issues with this renovation project was A, scanning the as-built structure, and B, potentially more importantly, figuring out how the hell do we install a contemporary facade system that is designed and fabricated to tolerance, watertight, really impressive design there that I cannot really disclose too much on, onto a superstructure that was built in the 60s. Well, we need to make sure that we're installing our fixtures in positions that are really, really, really accurate. So even though the superstructure is sort of all not entirely out of whack, but there's a lot of tolerance issues, we need to make sure that within that system, we can install the clamps in very, very predictable and accurate positions in order to then get the cladding to where it needs to be. So the problem is twofold. One, scanning and verifying the resolution of laser scans that, of course, are being performed on the structure throughout the whole renovation process. But the second and potentially more critical question is layout of those anchor points. So going up in a crane and actually installing the anchor point is not that big of a task, but going up in a crane and figuring out where that anchor point is around a cylinder, 150 feet up, really dangerous, very difficult, not fun at all. So the machine I'm working on, and I'm currently working on iteration 3.5, I guess. I'm showing you iteration 1 because it's already published. I sort of like to call it the koala robot because it's hugging the pipe in a way. So it's always in a constant relationship to the pipe geometry. So it doesn't actually rotate along the pipe. Wherever the pipe is, that's the axis of the robot orientation as well. So it's very custom designed for these particular pipes that this particular building is made out of. It can drive around it. It can be teleoperated. We have not yet implemented any autonomous driving, but that's on the to-do list. So the machine, again, performs 2 functions. One is it goes up and down the big pipes to verify our laser scan model. And the second one, which is these parts over here, and the second part that we're working on right now is basically adding a little Sharpie marker to the machine and a tiny little CNC end effector to have it go up a second time after the scanning and design phase are complete to actually label the positions where the anchor points need to be installed. These are some of our early tests on material. The climbing system works really well. if anything, maybe works too well. It's kind of too strong, so it sometimes gets stuck. We're currently working on systems for having variable strength magnet arrays, and again, the end effector. In terms of the software, and I'm actually out of time. In terms of the software system, we're currently working on properly integrating this into CAD, which I know sounds cool and also is practically impossible. So that's one of the big challenges we're tackling right now. But I guess for me personally, a more important challenge is to figure out how these machines can be not just tools for automation, but tools that end up in the hands of workers. So I do call them robots because somebody has to give me funding, and robots sounds really cool, but I sort of want to think about them as tools. Like, yes, they are automated. Yes, there's some robotic components, but they're not there to take tasks away. They're there to make tasks easier, which also comes with the scale of the machine. Again, throwing it in a suitcase, I can really imagine a construction worker on site kind of pulling one of these out of a Pelican case, because Pelican cases are really sexy, and, laying out the site and then going and installing the parts. So I guess I'll wrap here with this one of our early tests videos where in the background, sort of inside of, I don't want to judge, but slightly messy Zaner office at the time, we have the machine driving around. And up here, out of focus, you see the Leica total station system. And that's been a really important part of our project, integrating it into existing construction equipment ecosystems. So there's no unnecessary hardware that is not already on site. Leica total stations are part of our sort of high-tech but conventional tool set. So figuring out how to work with those, how to integrate these new tools that are very task-specific. This is where it loses the robot, which is adorable. Finds it again, keeps tracking. So the Leica is streaming points as the robot is moving around. It's streaming points back into our Rhino. And of course, everything comes back together in Grasshopper because that's the world we live in. And we get a sort of, it's not quite real time, but real-time-ish update on our CAD model. And here's where I'm going to wrap by saying that I hope you, join me in this endeavor of making tools that are architecture specific and not architecture that ends up looking like cars because it's somehow robot specific. And I would love to see this ecosystem continuing to grow, continuing to develop, and hoping to see more architecture robots in the future. Thank you.